Welcome to qnawire.
A standard cylinder of oxygen is used in a hospital and has a gauge pressure of 2000 psi, which is 13,800 kilopascals, and volume of 14 liters, at temperature of 295 Kelvin. How long will the cylinder last if the flow rate measured at atmospheric pressure is constant at 2.4 liters a minute? Okay, so our strategy is we want to find the change of the change of the amount of volume of air in terms of liters that have flown out of the cylinder, and then calculate the time at which this is done. So we start from the ideal gas law. So P1 V1 equals N1 R T1. So pressure times volume equals number of moles times gas constant times temperature. And taking the same for P2 V2 equals N2 R T2, and dividing through, we can take this and extend this and say that P1 over P2 dot V1 over V2 is equal to N1 over N2 dot T1 over T2. And we're going to assume that the temperature is constant inside and outside the cylinder. So T1 equals T2, so T1 over T2 is equal to 1. And similarly, we're not converting the gas to anything else, so it's going from the cylinder to the outside air, but the number of moles is not changing in essence, so N1 over N2 is equal to 1. So therefore we have, we're going to make V2 the subject in this case, so we're going to say that V2 is equal to P1 over P2 multiplied by V1. And in this case, that we know that the pressure is 1.38 times 10 to the 7 pascals. However, what we also know is that the we are going to convert this to atmospheres because our P2 is just given by 1 atm. So this is given by 1.38 times 10 to the 7 pascals is 1.36.19 atmospheres, but we also need to add on 1 because it's a gauge pressure, so it's relative to the outside atmosphere. So our P1, because the standard pressure anyway, because we're at atmospheric pressure, so we're at 1 atm. So P1 is equal to 137.178.19 even atmospheres. And V1 is equal to 14. Equals 14 liters. Now we have that P2 is just equal to 1 atmosphere, atm. And so then we are ready to substitute everything in. So going on to a new page here, we get that V2 from substituting everything in and just popping this onto a calculator quickly. So we have V2 is equal to 137.19. 137.19 multiplied by 14. Which is equal to 1920.66. So 1920.66. So 1920.66 liters. And our change in volume is V2 minus V1. So delta V equals V2 minus V1, which is equal to, so 1920 minus 14 is 1906.66. And dividing that through by the flow rate, which is 2.4, so delta V, so T equals delta V over the rate, and the rate was given by 2.4 liters per minute. So that is equal to 1906.66 divided by 2.4. I'm plugging that into a calculator. 1906.66. 4, and that gives us 794 minutes. So is equal to T is equal to 794 minutes. So 794 mins, which is approximately equal to 13 hours.